Hey, so in this video I just want to sort of wrap up this lesson. I want to discuss a few things in the Microsoft documentation on L values and R values, and then provide a few more examples on how you can initialize dynamic variables and arrays, since I haven't really talked about that in too much detail. So instead of doing sidebars on each one of these topics, I've decided to add it all in this one video. And at the end of the video I'm going to provide a comparison between pointers and references, maybe for your notes, and just go over some of those fundamental topics again so that you have those down before we move on to the following lessons. To start off with, let's talk about L values and R values. So I have a lecture on this, and I also talked about R value references. But in the Microsoft documentation here, you can see we also have something called an X value. So the C++ 17 standard defines expression value categories as follows. You have these things here. You have an L value and an R value. And then they also talk about an X value. So I have an X value here. Now this is basically an L value that denotes an object whose resources can be reused. And here's another example. An X value expression has an address that is no longer accessible by a program, but can be used to initialize an R value reference, which provides access to the expression. Examples include function calls that return R value references, and so on. So I have talked about R value references in the L value and R value lecture. So I just wanted to mention that there is a bit more to it than just the L value and R value that we talked about. But for purposes of our course, you only need to understand what an L value and an R value is. But again, you can go and read through here if you're interested in the other details. Next, I'd like to talk about how you can initialize dynamic objects that are on the heap. I discussed this briefly in a previous lecture, but I just wanted to provide a bit of a recap and a bit more detail on this. So I have an int pointer, which is a pointer to an integer. I create a new dynamic variable, an integer. You can use the parentheses to initialize that object. So the object or the integer on the heap will now contain the value 3. And we have to access that object using the pointer. Again, the object itself does not have a variable name that we can use as if it is the object itself. So I have to return the address of that object, store it in this pointer, and then we can sort of indirectly access it or change it using the pointer. Also have this pointer called array pointer, which is a pointer to an integer, and this will point to this array here. So I do new int. I use the subscript operator to specify, okay, this array will have 5 elements. And then I use list initialization. You should remember from our previous discussions that this list initialization, as it is empty now, will initialize all of those elements to 0. The same thing is going to happen when you initialize an object on the heap, as we are doing right here. Here I simply print out. So I do reference int pointer. That should print out 3, right? And then array pointer and some random element, and that should print out 0. Then I just do the delete again. So I delete the integer pointer. I set it to null pointer. I delete the array, so the array object on the heap pointed to by this array pointer. Then I set array pointer to null as well. Okay, I'll just build and run this, and you'll see it prints out 3 and 0. Now of course you can go and change this here, so you can set the values that you want to store in that array using this list notation. I'll do the first 3 elements and just do 1, 2, and 3. Again, using the comma operator to separate those out, and this will print out 3 and 3 now. Change this here to print out the first element, so element 0, 3 and 1. Now actually getting back to the integer here, so I have list initialization when we initialize the array. You can also use list initialization when you initialize another variable such as an integer and a float, as I mentioned in previous lectures. You can do the same thing for a dynamic variable, as you can see right here. Build and run, and that will work fine. I'll undo that because this is how you would typically initialize variables when you do dynamic variables, and then this is how you would typically do arrays. So you'd use list notation with a list, and then you'd use parentheses when you initialize variables. Again, you can decide on the conventions that you're going to follow. And also when you work at a programming company, they'll probably use conventions, or a game engine such as Unreal Engine. Maybe go and check out the conventions that they use, right? Okay, so I hope this clears up in a bit more detail how you can initialize an object on the heap. Okay, next I'd like to summarize some of what we've learned throughout this lesson on pointers and references. These are the important points that I mentioned. Of course, I talked about L values and R values, R value references, and so on. but I covered those in a lot of detail in those lectures, so I'm not going to go over all of those again. In the first row, we are comparing assignment between references and pointers. A reference, of course, being an alias for something else. You can also think of it as a constant pointer to that other object. But it's also not quite the same because a pointer you have to dereference, whereas a reference you don't have to dereference, right? You just use it as is, as if it is another name or an alias for whatever it is initialized to. So of course with a reference, to declare a reference, you give it a name such as demo reference, and you prefix that with the ampersand or the address of operator. Then you also need to specify the type. And as you can see with the reference, we do not use the address of operator to get the address of x. We simply initialize that reference to x, whereas the pointer in the right hand column is declared using an asterisk, so that star operator, and then we need to give it an address, because again a pointer stores an address. So moving on to the next row, we have a reassignment. So once the reference is declared and initialized, in other words it is assigned to some variable, it cannot be reassigned, so your reference cannot be made to refer to something else. You cannot set it to refer to something else, whereas of course with a pointer we can set it to point to something else, because it's just a variable that stores an address. So with the pointer in the right column again, we simply do the pointer name is equal to, and then you use the address of operator followed by the name of the variable or object. So in this case y, which is an integer. Moving on to the next row, we have reading contents or accessing contents. Now with the reference, we simply specify the name of the reference, so in this case demo reference. And in this example I do console output. Of course you don't have to do a console output, I'm just showing you an example. Instead of just doing demo ref, I want to show it in context of an actual statement. I feel like that's an easier way of demonstrating that. With the reference we don't have to do dereferencing or anything like that, we simply use the name of the reference, whereas with the pointer we have to dereference it, otherwise it's going to give us an address. So we dereference it and it should print it out. In the next line we have writing contents or changing contents. Now with the reference again we use that just like you would the actual variable. So you can either use x or you can use the reference name. So demo ref in this case, you set that to 15. Now when you do console output x or console output demo ref, in both instances you'll print out 15, because both of those names basically refer to the same thing. So x is demo ref and demo ref is x, right? With a pointer it works a bit differently. You again have to do dereferencing. So we use the asterisk or the star followed by the pointer name, the assignment operator, and then the value. And of course that can be another integer variable such as y, for example, but in this case we are specifying 15. Then in the next row we have the address, so if you want to get the address of a reference or a pointer, there are some differences here. If you go and get the address by using the address of operator of demo reference, and maybe you also print out the address of x, for example, when demo reference references that x variable, then in both instances you'll get the same address. They both refer to the same address basically. So the pointer is a bit different. If you do console output and ptr, then that is going to print out the address stored in the pointer variable, whereas if you do the address of operator followed by the pointer name, then that is going to print out the address of the actual pointer variable and not what it is pointing at. Then finally, if these can be null, the reference cannot be uninitialized and it cannot be null, so it must be initialized to an L value. And then a pointer can be initialized to null using null pointer. In older code you might see 0 as well, or null in uppercase as I have it in the first column. But again, since C++11 we specify a pointer to be null using that null pointer or null ptr. It's a good idea to use references instead of pointers if you can. Pointers are powerful in that we can set them to point to somewhere else or to point to some other object, but that can introduce problems as we've seen in previous lectures, where let's say you have a pointer that points to some object on the heap and you don't have another pointer that also points to that, and you set that pointer to then point to another object or to something else, then you have no way to get back to or to get the address of that object again. And this introduces memory leaks. So where pointers are powerful, they can introduce all sorts of problems. Also, if you have an object allocated on the heap, then you need to make sure to deallocate that object again to free that memory up again, right? You also have to dereference your pointer if you want to access the contents that it points to. So the pointers don't make things unnecessarily complicated by using pointers. If you can, use a reference instead. Okay, so I just wanted to provide a recap. There's a lot more, of course. We talked about arrays using the subscript operator. We talked about subscript notation versus offset notation and all of that stuff. But all of those notes are in those relevant lectures. I just wanted to provide another summary sort of comparison for you right here for your notes. So that will wrap up this video. I hope you found this useful, and I'll see you next time.